Thanks for joining us for Edge and Digital Transformation via SLE Micro and Rancher. My name is Brian Frome. I'm a Technical Alliance Manager here at SUSE. And my co-presenter today is Brian Gartner, a Senior Technology Strategist here at SUSE. Here are the topics that we'll be talking about today. I'll give you a moment to take a look at that. And let's jump in. Let's explore digital transformation as both a business opportunity and a challenge at the edge. So digital transformation is an opportunity for enterprises to engage with customers where business is happening. And really what businesses want, enterprises want from digital transformation is to create new digital services that generate new revenue streams by engaging customers in innovative new ways, of course, digital ways that are leveraging new technologies that customers really expect to see that expand beyond just the conventional web and phone interface to the corporate data center. And these new opportunities really leverage the plethora of data that can be collected at the edge, and we'll touch on that as well. But digital transformation is challenging because IT enterprises typically have, over the past 10 plus years, invested in web development as a skill set. And that's where the customer has been engaging in the past decade plus, is through the web and through the phone. And so those are the strengths today of the IT data center and the programming that goes behind it. And yet edge technologies introduce new technology challenges for a company. So let's look at those challenges. Edge technologies involve sensors, cameras, point of sales devices like kiosks or cash registers, and even phones. The customer phone is part of the application environment. And that introduces a whole new set of programming opportunity and challenge where programming at a device level might be written in a very low level language, whereas programming at the phone might be written in a higher level language. But yet both of those environments are even different from a web server environment. So the technology and the programming for those environments are very different. And then edge applications by their very nature are distributed. We have many devices and many sensors and many customers and phones, and they're all distributed as components in an edge application. And so that's really a distributed computing architecture. And that architecture is very different than the traditional web server architecture. And so again, there's a lot of retooling and relearning that has to happen for the enterprise, and that introduces a challenge. And then finally, big data analytics and machine learning and deep learning are both big opportunities for an enterprise to bring data into the picture and use that data to engage their customers in new and innovative ways, but they introduce new technologies and new challenges for the enterprise. So let's look at that from a graphical perspective, sort of a picture of this view that I just talked about. On the left, we have the conventional data center approach to web development, which is what most customers are used to today. We, interface with the company through the website or the phone. And that's not to say that the application development there is simple. There's lots of technology stack and typical application management needs like security and performance and scale and all the things that you can imagine in an application management environment. On the right-hand side, then, we have the edge environment. And as we talked about, introducing many new different technologies from devices and sensors and phones that all build together into the place where the customer is engaging. And today we'll talk about a point of sale model or a use case that we'll use to exemplify edge technology and edge programming and the technologies that build up the programming for these applications that need to be delivered. Let's go a little deeper into our point of sale use case. So we're talking about moving stores from the more conventional brick and mortar approach of a customer walking in, finding what they want, buying it, and leaving, to a more digital experience where the customer, not only does the store recognize the customer, but the customer engages with the store in new ways, maybe through point of sale devices like a kiosk, but also through their phone. And as we talked about earlier, the technologies to implement this are very heterogeneous. So, written in many different programming languages, some new to the IT development experience, especially around devices, low-level devices that might be managing a sensor or a camera. And then other aspects of the environment are things like the environment is must be much more resilient. Certainly, a website environment needs to be very resilient, but there are IT administrators there that when something occurs, they're immediately alerted and people can jump on and look at the problem and start diagnosing and curing the problem. And while that can happen in an edge environment, the components themselves may come and go. Like a component may need to reboot for some reason. Maybe it just runs out of memory and needs to reboot. So we sort of develop our application to expect these conditions. And so we're seeing things from a much more heterogeneous viewpoint and a much more distributed viewpoint. And that leads us to this pet versus cattle mentality, where rather than having the pet mentality is more what you think of in the web environment, where we have a virtual machine that is the stack of software, and we want to take good care of that and configure it a certain way, and then don't touch it, right? When it's left to be, that way until the next time we make changes and test those new changes. In the cattle world, we have components that are much more separate from the dependencies across the application. And then the distributed application keeps track of, oh, there's a component, it went away, I better restart that component for, let's say, managing or monitoring the cameras, or even for pulling data from a camera. And so, that cattle approach is a very different technical approach to an architecture than the pet approach. Other aspects that are new and challenging for an enterprise are the aspects of distributed computing. The topology is very different. We have wide area networking and even Wi-Fi within the store that typically, in a website, your network is very contained to the data center and you have very high speed networking and it's very well managed by the enterprise, whereas Wi-Fi is available to the customer. And so security is quite different. And sometimes you need, in fact, not sometimes, you need to look at the network as less secure because you've got pieces of components on the network that are part of the application environment that aren't really as secure as you would have liked them to be, like the customer's cell phone. And I mentioned at one point that there are no on-site administrators in a store. So that's a challenge, right? Certainly we can do remote administration and look at and monitor what's going on within the entire network. But because there's no one there to go poke at things on site, typically the components need to be much more resilient. They need to take care of themselves and reboot as necessary or do updates as necessary. And they can't fall in a hole and pull down some update and find themselves in a state they can't reboot. That's just not acceptable. So the componentry needs to be designed in a way that's much more resilient. Other aspects of the edge environment are that the technology is evolving very quickly. So the APIs and the programming environments for the various components are not only very different, very heterogeneous, but some of them are very mature and some of them are very not mature, immature. And that's important and complex because some maybe camera devices that we're interested in using may have a somewhat weak programming environment, and we need to wrestle with that from a technical standpoint and still maintain these aspects of security and resilience that we talked about. So again, those introduce challenges to the programming. And cell phones themselves certainly add another layer of complexity. They're in and of themselves very different in terms of their programming. And they often, the cell phone toolkits think of themselves as, there's a cell phone and there's a cloud website. And that's not really the architecture here. There may be a cloud server that we communicate with, but that's not the only aspect of the way we might want to use the phone. And so we might want to think of the phone as more integrated into a network environment, so that we recognize things. Even just when the phone gets on the networking, on the Wi-Fi, we'd like to recognize that phone and maybe grab some information from it to identify, oh, that's a specific customer, or a customer that we know of that we might want to send some information to. And I mentioned artificial intelligence. Machine learning and deep learning are amazing technologies that can leverage the plethora of data at the edge, but they also are new programming models. The model is new in terms of the way the programming is done. Data science is a new aspect of the way to think about the way the applications are built, and is a specialty in the way that knowledge needs to be brought to the programming problem. So that introduces a whole new set of complexity for actually building the application. And then finally, digital transformation is about more than just writing services. It's really about getting services to market quickly and moving fast at the way we learn about what services work well for customers. And agile software methodology fits that very well. Traditional software methodologies, where we build a large system and we release the large system together, and maybe that takes many months, maybe even a big enough system takes a year or more to develop. In an agile methodology, that's not the way we do it. We release very often, and we examine, we try to work closely with customers to get feedback. So we ask good questions of customers about what they're experiencing with these components they're using, and use that information to drive the service towards something much more useful for customers. So that agile methodology is really key to how we build sophisticated edge systems, and yet it's new. So it's not new as a concept, it's new to many IT organizations. So again, it adds a new level of complexity and software challenge for an IT organization. Now we're going to switch gears and talk about the infrastructure that implements these edge applications. And I'm going to pass it to my co-presenter, Brian Gartner. Brian?
Thank you for that handoff, Brian, and great job talking about why customers might want to head down this path, and even more importantly, if they're on that journey, how we can collaboratively work together to make it even better. All right, let's dig in a little bit further now into the edge infrastructure itself. Okay, let's talk about this in the application environment or a solution stack kind of context. And let's start at the bottom layer. The computing platform, where is that? What is it? I mean, it could be a hardware vendor that provides it. It could be managed service providers. It could be cloud service providers. And when you go up another layer, it's what's the software components that make all of that infrastructure available for things like your operating system, for like Kubernetes, and managing all that thing so that you can do things at the edge whenever you need to, and also interact with that from somewhere else. So a lot of times the next thing up is the infrastructure as a code, is how to automate this. Because again, once you're talking about edge, you are talking about probably lots of devices everywhere in a distributed manner. So you want to automate those things. And of course, the next layer up is the workloads. What are you actually running to make your business need, to meet your business needs, to help you improve the customer relations, the interaction with the other folks, getting the data that you need to make the right decisions, the business analytics and things like that. That's what all that layer is about. And that's what all those layers below it provide the foundation of. And then you can also do things like how employees need to deal with this stack of technology, right? So that they can do the right thing when they need to. With that said, let's move on to a little bit deeper level. Okay, so let's drill into the software infrastructure at the edge kind of a bit. And we'll do this in one of verticals of like a retail, of how do you move from just doing brick and mortar kinds of things towards more digital service as you're doing that digital transformation and whatnot. So one of the things you want to probably do is simplify the infrastructure stack, okay? And you don't want to do everything as a unique thing. You want to do it as probably edge tailored, not necessarily a one-off. And you want to standardize probably because you're going to move forward with a cloud native landscape. of doing cloud native applications and whatnot, Kubernetes has become the new floor. And everything below that, you look at it as overhead and you think, don't worry about that stuff. I just want to make sure that my applications that I run, that I buy, that I use, can land on top of those APIs and do what is needed to do. And still, though, you have to, at least some of your team has to take care of what's the capable hardware platforms, from really tiny little edge devices all the way from sensors, all the way to just edge computing to gateways and things like that. Those are probably not going to all be one-off, but you will have examples of different ones, and it is a very distributed and non-homogeneous probably thing. But what you want to do is basically making sure that the devices can do control functions if needed. So if an analytics thing decides that you need to tweak the heater or something in an environment for manufacturing, or the oven in a bakery, or whatever it is, you need to be able to control devices that are outside of that. You need to be able to do things like ML and DL so that you move the computing aspect closest to the edge data and do the right thing as fast as possible. And you might want to do big data analysis as well to kind of pull that data in to make bigger decisions and trendy decisions to move forward faster. Okay, so let's talk about an operating environment. Again, it feels like it's underneath that floor of Kubernetes is the answer, but it is one aspect that's really important when you're talking about edge devices. And there is a product out there, and there are other presentations at SUSECON. I encourage you to go out and find those about SUSE Linux Enterprise Micro. It really is an edge-tailored operating system. It has the same kernel as our enterprise server, so you benefit from all of the hardware enablement and whatnot, and the certification is in place for it. But what it provides is a couple of things, and some of the things are like transactional updates. In other words, to eliminate problems that exist between the keyboard and the chair of doing upgrades or whatever, you do things for a read-only file system, and you do it into a snapshot, and you do that as a transaction. Then it reboots into that new mode, and if things are successful, cool, way to go. And if not, it can roll back immediately for you. Furthermore, you can rely on the security aspects and the models that are there. So again, that read-only file system makes it very tamper-proof. And you can do things like SE Linux to manage exactly what can do what and where on that device. It is able to run bare metal services as a package. It can run containers directly, or you can do Kubernetes on top of it as well. And that means that you can run any of those workloads you need on a device like this with SLE Micro. And from that small edge devices, whether it's something like a Raspberry Pi with an ARM64 architecture, or a very specific hardened x86 platform, you can do all that. And again, those services are all for you to use. Okay, let's talk a bit about the application environment, that infrastructure piece between what your workloads are and below. So, of course, in this era, and Kubernetes has become the container orchestration platform that you want to use to distribute those workloads wherever they need to run and however you want them to run. Okay, and again, it follows that cloud native architecture and that cloud native landscape. What's interesting, though, is once you go down the path of Kubernetes, you can deploy Kubernetes everywhere and use it for everything. And let's go into like why you would do this in the edge space. So if you look at the Rancher product K3S, it is a very edge-tailored Kubernetes infrastructure. It runs on small devices. Again, those same things that I mentioned on the previous slide with SLE Micro. You can run it on very small devices or gateways or edge computing platforms and things like that, so that you can do all of those Kubernetes workloads on top of that. And it's very easy to deploy and whatnot. We'll talk about that later. When you go up a layer now, okay, so we have 1,000 of these edge devices all over the place. How do you manage that? SUSE Rancher is a multi-cluster management tool. And it's not just to manage edge devices. You can manage the same Kubernetes. You can manage Kubernetes infrastructures in your core data center, in the cloud, and at the edge. And it's all through the similar interface. Okay. Then there's a tool called SUSE Manager that allows you to manage so while SUSE Rancher and Kubernetes, they focus on the Kubernetes layer and interactions with the underlying layers. SUSE Manager helps you do the OS layer and managing to the hardware layer and things like that. And it also makes it very easy to connect it and deploy things like K3S and also poke it and say, okay, now you're a member of the Rancher cluster management. Okay, to kind of sum it up of what we talked about in that solution stack space and the products, if you look at the portfolio that we just described and how we can cover the entire gamut for customer sake, of course, you can deploy at the edge. I'm working on the bottom layer there, or it could be a branch office or a retail outlet or something like that. And then the OS that you might want to consider using in those contexts are something like SLE Micro to get that transactional read-only update with all the security aspects and the maintenance easily to do. And then furthermore, with SUSE Manager, then you can manage those devices that way and that operating system and whatnot. And then when you go to that top layer, you can deploy K3S. That is the Kubernetes infrastructure piece that you need to run all your cloud native workloads, containerized microservices, things like that. And then with SUSE Rancher, again, you can manage all of these devices, no matter where those are. And I'll give you hints. We're going to talk about some of those other places that you can do this with. Okay, so let's talk a little bit, and you kind of get the feel that maybe in the last section I was talking about more the ops side of the world. Let's talk a little bit on the development side of the world, how you interact with all of this stuff that I just described. Okay, so let's talk about a couple of aspects here, and it's more about the application development and the characteristics you need, and why this could be a vehicle to make this very possible. Of course, even in this remote environment that has happened during the pandemic and whatnot, the application developers don't sit at the edge next to that little device. Okay, they need a test environment where they can make sure that the applications work as expected. And if you think of it in terms of like a CI/CD pipeline, what you want is the same environment somewhere else, so that I know that it'll work when it lands someplace else. Okay, and so you can create this test automation to spin up a test edge environment. You can build and deploy those containers. You can run this test suite. You can store the results, tear that environment, and lather, rinse, repeat as much as you want. And we'll go into this a little bit more on the next slide. Okay, so when you're talking about the characteristics at a little bit leaper level, right? We mentioned Rancher and K3S. It runs on IoT devices like edge computing, like gateways, whatever, even like a Raspberry Pi or specific edge servers and whatnot. But it can also just simply run in a Linux VM, which means now I could deploy it on my laptop or anywhere else that I need to. And literally from a deployment standpoint, it's one command to spin that up and do that. And then it's one command to import it into the Rancher server to be managed that way if you want that, although you don't have to as a developer. But what you've seen now is you have the same Kubernetes across the infrastructure, whether it's in the dev space, on my laptop, or on that edge device that I really need to run it on. And once you go down the path of doing something like GitOps with infrastructure as code, that means that that deployment of that infrastructure can be done and automated and maintained and updated and it just makes it very, very easy to do. Okay, let's focus on now managing that infrastructure, because we've made our developers potentially happy that they can have an environment to do what they need to do and make sure that it will work. But how do we manage that distributed infrastructure? And we're talking from edge to core and even into the public cloud. Okay, so kind of related to the solution stack space, these are kind of those same elements that you need to think about is, where does the application deployment happen? The security aspect, that's very important in policy and monitoring the things to make sure that they're always working. How do I make that infrastructure as a code happen to those distributed edge systems and devices? And with that, I'm going to go over several products that make this possible that I've mentioned earlier, but we'll go into a little bit more details. Okay, let's start talking about SUSE Rancher. And this is about managing multiple Kubernetes clusters. And again, as we've described, there could be thousands of edge devices. Each one of those could be individual clusters. Okay. And what SUSE Rancher gives you the ability to do is have that portal to go manage those. And it could exist in your data center. It could exist in a public cloud provider. And it has that infrastructure as a code mentality to automate the edge, not only to deal with Kubernetes versions and things like that, but also how to manage your workloads and who can do what. We'll talk about this more later. But it does raise that production quality of making sure there's enough uniformity of wherever you need it, or the versions that you need to be running are in place on a certain spot. So you can tailor things for policy management, for process needs, things like that. You can label nodes certain ways, you can label clusters certain ways. You can define projects that are multiple things and multiple namespaces and things like that. But what it really provides is that consistent floor for those applications so that I'm just going to create a containerized microservice that runs Kubernetes, relies on Kubernetes APIs, and you want it deployed to where? Oh, point and click, done. Okay, so let's go a little bit deeper into that. Okay, let's talk about some of these core attributes that really help address some of those edge concerns and challenges. Okay, so SUSE Rancher has the ability to do monitoring and alert. You can audit things, you can do diagnostics, you can do full-blown node management, even provisioning if you want. You can also change roles for the nodes and things like that. It has the ability to deploy and do storage management. And you can also, again, like I mentioned last time, you can have a specific version of Kubernetes there. And when you're ready to do that upgrade, again, point, click, and it does it for you. In the security and authentication space, this is very important because chances are really good that you're not going to just have a couple people doing all of this. You're going to have lots of various groups of folks that need to do what they need to do. And with the single sign-on capability where you have things like LDAP or Active Directory plugged in, now you can make it open to those users, and they get that authentication piece so that they can do what they can get in and see what they can see. And then later on, I'll talk about the role-based access control where you can say, yep, Brian, you can log in here and you can see all the clusters and you can see everything working. But that doesn't mean that you're going to muck about and do anything else. You can't redeploy the cluster. You can't upgrade it. You can't do this, whatever. Okay. Or again, that role-based access policy can change and say, yep, Brian, make sure that you manage these 3 out of these 1,000 clusters. And you can deploy workloads on 2 out of those 3. Okay. Furthermore, you can do things like CIS benchmarking to make sure that it's always in a secure state. And you can go another level down of managing security policies of, okay, for this deployment, these 2 pods can talk together, but that doesn't mean they're publicly visible or publicly available or pokeable from a given port. Okay, and then the same thing in the network space. But essentially what you're being able to do is that configuration management and enforcement. Okay, let's talk about SUSE Manager, and you'll notice that I called out for retail because it already has the ability to do a tiered management of in the core, at a branch office, at a far edge thing and things like that. It has that capability already, and so we're going to leverage those capabilities to do this in the edge context now as well. And I can do system deployments, whether that's plug in a new device when it comes online, put a new golden image on it, and then I can also do the patching of it to make sure that it's patched and up to date because that golden image, oh, that was a week ago, and there's security updates. I need to get those involved. Okay. You can also do the subscription management, which of course it registers to these nodes, these SUSE Manager nodes, whether it's the proxy or the actual central one, so that it can see, oh, not only do I want to see this, I want to see this other package, this other set of packages and whatnot. And you can make that enabled and whatnot. And it could be that it could be a deployment where K3S is deployed. And oh, by the way, once it's deployed, then also connected to the Rancher server. Okay. You can do configuration management. So you can do very specific things of saying, we need to change all the admin passwords, root passwords, or whatever, because our lead IT architect left or our operations team. So you can go do things like that. You can do compliance management to make sure that the security is up to date, the policies are in place, things like that. And not only that, you can manage not just SUSE Linux enterprise distributions, but also some other Linux distributions, whether they're community and or enterprise themselves. And with that, I'm going to wrap up and I'm going to turn it back over to Brian to give you the summary. Thank you very much.
Thanks, Brian. So let's summarize what we've learned today. Digital transformation is a business opportunity and a challenge for many enterprises. And yet, it's very important for the enterprises to consider how to compete by bringing digital services to their customers and bringing their customers and the business closer together. So we've looked at technologies that we use to make the problem more uniform and more uh, simplify, really, to simplify the application environment so that the plethora of technology challenges is reduced um, by leveraging common technologies and moving up into the container space to manage containers and manage the application development in a new way. We'd like to leave you with some resources on places to go get more information here. So um, when you go grab the slides, please, feel free to grab these links. And there's a number of pieces of documentation. There's also training. Rancher has some great resources available to get started with Rancher componentry, and as well as move quickly into a proof of concept with these technologies. So I hope you enjoy some of these resources, and I want to thank you for your time today. It was fun to engage on the topic, and we're looking forward to talking more with you about these challenges and opportunities. So let's consider creating a brain date location as part of SUSECON. If you haven't heard about brain date, go look it up as part of the SUSECON site, and we'll see if we can chat with you more about this there. Thanks again.